So hello friends, assalamu alaikum. Today we are here with another other dynamic problem, that is 12.10. This problem is quite similar to that one that we have yesterday solved. So let's see what is this. For a short time, the path of the plane is described by this is the equation of the path that the plane is covered. That is what y is equal to 0.001 x square. If the plane is rising with a constant velocity of 10 मीटर पर सेकेंड, अगर प्लेन इनके 10 मीटर पर सेकेंड की कांस्टेंट वेलोसिटी के साथ राइज हो रहा हो, इनके फ्लाइट उस अप हो रहा हो, तो कहता है कि डिटरमाइन करें उसकी वेलोसिटी और एक्सेलरेशन कहाँ पर जब प्लेन 100 मीटर की हाइट पे पहुंच जाए, यानी कि दिस डिस्टेंस इज़ इन एक्स डायरेक्शन एंड दिस इज़ द equation of the path on which the plane is rising up. So we have to find the velocity and the acceleration of the plane. So we collect our data that the equation of the path is 0.001 x square, and the velocity, that is the constant velocity, what is that is 10 meter per second this is in y direction, and we have also the height, that is in y direction, what is it, 100 meter per second meter. So first of all, we have given that y is equal to 0.001 x square. From this equation we can easily find the value of x what the horizontal distance. So putting the value of y, that is 100, 0.001 x square, by shifting this to the left side, this is, and by solving this we will get the value of x, and that is 316.2 meters. This is the horizontal distance that the plane covers. Now we move to the velocity component. Now we find the time taken by the plane to reach this height. That is, we know that velocity is equal to displacement or distance over time. So we know that the velocity is given, that is 10 meter, and we also given this distance, that is 100 meter is equal to t in seconds. Sorry, there is some mistake. We have to find t, we shift t here, and y upon vx by putting values. Y is equal to 100 upon this vy, sorry, where is vy, this is 10 meter. So t is equal to 10 seconds. The plane will take 10 seconds to reach this height. Now we move to find the velocity in x direction. We have find that velocity in y direction. Now we find the velocity in x direction. For this we are given an equation, y is equal to 0.001 x square. We know that to find the velocity we differentiate the distance. By differentiating this we will get, this is constant term, the 2 is in product, and 1 minus from this is x, and the derivative of base. Now we solve this one. This is actually the derivative of this equation is equal to Vy is equal to 0.001 into 2x dot x dot. So we have find the velocity in y direction that is given in the question, that is 10, 0.001. We have also given the value of x that we have just find 316.2. Here we find the value of into x dot. This x dot is what? The velocity in x direction. By solving this, all of these terms shifted to this side. 0.0012 into 316.2 is equal to, we can write this as the velocity in x direction. By solving this, we will find the velocity in x direction, that is 15.81 meter per second. This is our velocity in x direction. Now we find the magnitude of the velocity. We have discussed this in our previous video, that to find the magnitude, this is the formula. The velocity in x direction is what? 81 square plus the velocity in y direction, this is. By solving this, we will find the velocity in the terms of magnitude, that is 18.7 meter per second. This is our velocity in terms of magnitude. Now we find the acceleration. In previous video, we have learned that acceleration is what? The velocity. Acceleration is what? If we differentiate the velocity, or if we then we calculate the acceleration, or if we differentiate the distance twice, then we also calculate the acceleration. We have already differentiate the distance in to find the velocity, that is 0.1 to x dot x. This is our velocity that we have just calculated in y direction. Now if we again differentiate this one, then we get the acceleration in y direction. So let's do this. By differentiating this, these are the constant terms, we separate them, and these are our variables. We apply derivative on them. We can also write this as ay, the acceleration in y direction. So these are constant terms. We again apply the derivative formula u into v, that is what? The derivative of the first term, the derivative of x is 1, and next what? The derivative of the base, that is x dot. The second term will remain same, plus first term will remain same, the derivative of the second term. This is what? The derivative of the first term, and the next is the derivative of its base. Base is what? X. Then this is the derivative of x, and this is the second term will remain as it is. Now 2 into 0.001, these both of these are same, so we can write them as their square, plus x. This is what? The second time derivative of that distance in x direction, that is the acceleration in x direction. So as we know and given in the question that the plane is moving with the constant vertical velocity, that is 10 meters. So we know that if the velocity is constant, then the acceleration in that direction will also become 0. So the velocity in y direction will become 0. And now the x dot, what is the x dot? The acceleration velocity in x direction that we have just calculated, that is what, 15.81 meter per second. And the x is what, the horizontal distance we calculated in the start of the problem. But now we are substituting these values. 2 into 0.001, this is x dot, here is its value 15.81 and its square, plus x, this is 316.2 into ax. Now we shift these values to this side. These are in product, and here upon this will become 0. 15.81 square plus 316.2 ax. We shift this to the left side, this will become negative, and this will become in division, and this is it. Now by solving this, we will get the value of the acceleration in x direction. So that is what, by solving this, we will get that the acceleration in x direction is minus 0.791 meter per second square. The negative sign shows that this is a retardation. Retardation means the negative acceleration. Now we find the magnitude of the acceleration, that is what, the same we have just calculated in our previous example, plus ay square. The value of this one is minus 0.791 whole square, plus this will become 0 because our velocity is constant. At constant velocity, the acceleration will become 0. So by solving this, we will get the acceleration, that is 1 meter per second square. So this is our acceleration. So friends, if you like my video, then subscribe my channel and hit the like button for more interesting videos about engineering dynamics. So Allah Hafiz, अपना ख्याल रखिएगा.